So the next big topic in Algebra 2 that you need to walk in and understand, and then you'll do even more with it next year, is called factoring. And you did this in Algebra 1, and it trips up some people, and in my opinion, it's because we don't spend enough time on it. And that's nobody's fault, it's just that there's so much stuff to cover in Algebra 1 and Algebra 2 and only a school year to do it, and maybe less now, that you just don't spend enough time. So here's the extra time you need right here. So first I wanted to find out, let's see if it actually is fun. Everything on the internet is true, I was told, so let's see. Can't find anything there. Let's look at images. Oh, this looks fun. Factoring has something to do with flowers. This one says it's fun right here. Factoring fun. Fun again. Fun with quadratics, yeah. Okay. This happy factorization doesn't look very happy though. I'm not sold on that one. Can play Wheel of Fortune factoring. Wow, this is a great topic. I had no idea. Alright, so now the guy looks like an angry version of me. So we've proven factoring is fun, so now let's try it. Alright, real basic stuff. Write down the number 12. If you were going to factor number 12, what are two numbers that multiply to make 12? That's what factoring is. Factoring is finding numbers that multiply to make the product. And those are called factors. So we could do 4 times 3. You could have also done 6 times 2, but I chose 4 and 3. And you want to get to the prime, 3 is a prime number. You did this probably in 7th grade or 6th grade. But 4 can be broken down into 2 times 2, and those are both prime. So I just factored the number 12. Okay, not hard to do, because if you know how to divide, then you can factor. The number 30. Write down the number 30. Let's see, you could go 10 times 3, you could go 6 times 5. I'll go 10 times 3. Oh, 3 is a prime number. But 10 is not. 10 can be broken up into 5 times 2. And it just so happens that 5 is prime, 2 is prime, and 3 is prime. So there, I just factored 12 and I just factored 30. The trick is, that's not algebra. There's no variables in there. So what if we had to factor something like this? Write down 5x squared plus 15. We wanted to find something. This is like a binomial, right? There's a term here, because it's separated by this, and a term here. What goes into both 5x? What's a factor of 5x and also a factor of 15? What's the greatest common factor of 5x and 15? Well, 5 goes into 5x and 5 goes into 15. So 5 is your greatest common factor. They call that greatest common factor. And we've identified that as the number 5. So I'm going to write down 5, and I'm going to put some parentheses. Now really what you're doing is taking this 5x plus 15 and sort of dividing it by that 5 you just came up with. So 5x divided by 5 is just x, and there was a plus sign, and the other term, 15 divided by 5, is 3. So this is your factored answer, 5 parenthesis x plus 3. And you know you're right, because if you redistributed 5 times x, 5 times 3, that's 5x plus 15, which is what we started with up here. Okay, let's try another one. What goes into 3x that also goes into 24? The number 3 does. So the greatest common factor is 3. And really what you do, if you wanted to show this work, you could. You're really dividing them both by that number. Or it's not always a number, but that term. So 3x divided by 3 is x. 24 divided, oh, that's a minus sign. 24 divided by 3 is 8. That is your factored answer. And just to double check, you could redistribute and go 3 times x is 3x. 3 times 8 is 24. 3 times negative 8 is negative 24, and you're right back to where you started. All right, another one. What goes in to 3x squared and to 9x, both of those terms? This is a little bit different because it's more than just a number. This has a factor of 3 and an x, and this has a factor of 3 and an x. So let me break this down a little bit further. I'm going to rewrite this. 3x squared plus 9 times x, and really 9 could be broken up into 3 times 3 times x, right? So look at it that way. What's here that's also here? You could take out a 3x out of that, and you could take a 3x out of that. That is cool. I did not expect that to work out that cool. So I took out a 3x, and look what's left. X plus 3. If I redistributed, I would have 3x squared, and I would have 9x. So that is correctly factored right there. Let's try it again with this last one. 40x squared minus 10. 40x squared could be broken up, think of it this way. 10 times 4 times x times x. That's 40x squared. Try it this way. What's in both of those things? A 10. Right? So I could take out a 10, and that would leave me with, right, if I took this 10 and put it here, and I took this 10 and put it here, now I just have 4x squared minus, nothing's there. When nothing's there, you've divided it by itself, and it's really a 1. It's not a 0. It's a 1. Okay? And this part can actually get factored further, but you don't know that yet, so hold on. Well, you may have known it, but we're not going to cover it yet. All right, so let's try it when there's 3 terms. Down, and now you have to find something that goes into 2x squared, that goes into 8x, and that goes into 12. Well, there's only x's on the first two, so you can't pick an x because there's no x over here. But the number 2 looks like it fits into everything, so let's try to take out a 2. And really, remember what I told you? We're dividing by the 2. So when we do that, we're left with x squared. Same sign. When we do that, we're left with 4x. Same sign. And when we do this, we're left with 6. There's your answer. Some people forget to put that 2 out there. That's part of the answer. That's one of your factors. And this last one. This one does have an x, at least one x in every spot. And it looks like the number 2 also. 2 goes into 8, goes into 6, and it goes into 10. So I'm going to take out a 2, but I'm also going to take out an x because I can. So if I do that, remember I'm really dividing by that 2x. So now I have, let's see, 4, and I had x cubed. I divided by one of the x's. Now I only have 2 left over. Minus. This is a 3. I had x squared. I divided by one of them, so now I just have 1. Plus. 10 divided by 2 is 5, and those x's cancel. So that's totally gone. And that's my final answer. So dividing is really how you factor a greatest common factor out. You always look for a greatest common factor first when you're asked to factor. Now, switch gears completely. There's other ways to factor. That's just one way. The next way, and the only other way we're going to talk about today, is difference of two perfect squares. I think this is the easiest way. And once you remember it, you probably would agree. When you have two squares, difference of two squares, so difference means minus. It has to have a minus sign. Okay, it can't be plus for this. It's got to be a difference, a minus. In both terms, there'll always only be two. Both terms have to be a perfect square. Well, x squared is a perfect square because the square root of it is x. So remember your numbers. Let's write them up here. Your squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. Wait, I want to keep going. 11 squared, 12 squared, 13 squared. Okay, now I'm done. For now. So those are your perfect square numbers. So whenever you see those fancy numbers, it's tip off that it's probably a difference of two squares. So a square, well, first let me tell you this. When you're factoring these, it's always going to be two parentheses, two sets of parentheses. The square root of x is x. The square root of 9 is 3. 1 plus, 1 minus. Every time like that. Look at this one. Square root of 16 is 4. They both start off with 4. The square root of y squared is y. 1 plus, 1 minus. Done. Alright, and the last two, same thing. Oh, there's a perfect square. 81 and y squared, perfect squares. Right off of our memorable list right here. So it always starts off with two parentheses. The square root of 25 is 5. The square root of 81y squared would be a 9 and a y. A 9 and a y. 1 plus, 1 minus, done. Okay, and one more. Oh, 36, and an x squared, and a 49, and a y squared. All perfect squares. So we have two sets of parentheses. The square root of 36x squared would be 6x, 6x. The square root of 49y squared would be 7y, 7y. 1 plus, 1 minus, done. So that, I think, is easier. When you're dealing with difference of two squares, you just have to recognize and try not to forget these numbers up here, because those are your kind of clues that you're going to have this type of problem. When you see like a 9 or a 16, 25 or 81 or 36 or 49, they're all part of that list. So you just square root both sides. One's always plus, one's always minus. And then don't forget about difference of two, or greatest common factor, which we did earlier. So now you're going to try these. There's the first one you're going to try. Write down 2x squared minus 8x. And I'll give you a verbal hint here. You're going to take out a greatest common factor of 2x. And then you're going to divide by 2x, divide by 2x. And what is the answer? Number 2, the greatest common factor here. Let's see, what goes into 30 and 35? Looks like a 5. But there's also an x on both sides, so I'm going to take out a 5x. What you're going to do is divide both sides by 5x. So 30 divided by 5 is what? X squared divided by x is what? And then tell me how it finishes. What's the answer to that? Number 3, difference of two squares. Oh, there's that 121 and x squared. So it's going to be two sets of parentheses. The square root of x squared goes here and here. The square root of 121 goes here and here. And one's plus and one's minus. What's the answer? Here's the last one. What's the answer to this one? See you tomorrow.